Ever wondered how we can prove that a midpoint truly splits a line segment into two equal parts? Today, vectors will show us the proof. The midpoint theorem states, if M is the midpoint of AB, then the position vector of M equals half the sum of position vectors of A and B. In vector form, M equals A plus B, all divided by 2. Here A and B are position vectors of points A and B from origin O. We can prove M is the midpoint by showing vector AM equals vector MB. This means M divides AB into two equal parts. Example 1. Point A is at position 3i plus 4j, and B is at 7i plus 2j. Let us find the midpoint MM. We substitute into our formula. M equals bracket 3i plus 4j plus 7i plus 2j, close bracket, divided by 2. This gives us 5i plus 3j. Example 2. P is at coordinates 2, 5 and Q is at 8, 11. Find the coordinates of midpoint R. For coordinates, we average the x values and y values separately. 2 plus 8 over 2 gives 5. 5 plus 11 over 2 gives 8. So R is at 5, 8. Common mistake. Many students subtract the vectors instead of adding them. Always remember, midpoint uses plus, not minus, in the numerator. Memory aid. Think of midpoint as the mean of two vectors. Add them together, then halve the result. Write this formula in your exam. M equals A plus B all over 2. Subscribe to Ovasaabi for more mathematics lessons. Visit ovasaabi.com to access past papers and extra practice questions. Keep learning.